I'm going to go through some things on here. If you guys have questions, obviously, just let me know. But I'm going to kind of make a video go through some of these things so the ones that are gone can kind of get on here and watch that. First two should be piece of cake. Inverse is just switching x and y, okay? So if you got ordered pairs, just switch the ordered pairs around. If you have an equation, all it's asking for is an equation. If it's not asking for the inverse, you don't have to solve for y. So all you have to do is switch x and y, and you don't have to solve for y on number 2, unless you really, really want to. But you can just switch them and be done. Okay, number 3, we are graphing the original and the inverse on the same graph. And that y equals x line is that line that we talked about that is our reflection line. So you don't necessarily have to draw that in there, but I always like drawing it in there just because that's the line that we're reflecting it over. And so it's kind of a good visual of what's going on. The original function you can graph in your calculator, x squared minus 5. And so we could come up with some ordered pairs really quickly here. I'm going to actually go plug in. I'm going to plug in 2 instead of 1 and negative 2. So if I plug in 2, 2 squared is 4. 4 minus 5 is negative 1. And there would be 3 quick and easy points. And you could get those right off your calculator if you wanted to. You don't necessarily have to come up with them on your own. So there's our original graph, plotting those 3 points. Okay, I'm just going to do mine in a different color. I know it says a dashed line versus a solid line, but I'm just going to do mine in a different color. We're going to flip-flop the 3 ordered pairs that we have. You can do more than that if you want to, but 3 should be sufficient. And there's our new graph. Okay, and some things that you can think about, and that's why putting this y equals x line in here is kind of helpful, is because this point reflects here. So 0, negative 5 reflects over here to negative 5, 0. And so all these points are reflected right over that line, and you can kind of see how they all kind of coincide with one another. And that's why putting that line in there kind of helps. Okay, so that's all you got to do on that problem, is just, and the reason why we flip-flop the ordered pairs is because if I just switch x and y and say x equals y squared minus 5, I'm not going to be able to put that into my calculator. And so I just want to take some points, flip them, and then use that to make my graph. Okay, the horizontal line test is just the opposite of the vertical line test. The vertical line test, we run it across vertically. Horizontal line test, we run it across horizontally. If I touch more than one point at any given time, then it is not a one-to-one function. And so then this one would simply be no, just horizontal line test. Okay, number 5 is the same thing you do number 5. The only difference is you have to graph it yourself. They don't give you the graph on this one. Remember, especially for TIs, we've talked about it a couple of times. Absolute value is hidden under the math button, so you have to go math and then num and then ABS. Go to your y equals first if you're going to graph it, and then you can go and put your absolute value symbol in. Okay, 6 is very similar to number 2, except for one thing. When they ask me to write the inverse of the function, I have to solve for y. So the first thing we're going to do here is x equals 7 minus y. But we're not going to stop there. And if you look at your 4 options, none of those options show up. So what we have to do now is solve this equation for y, get y by itself. This is kind of like the one we did on the front page. You put that in there. We only have 3 points here. So take these 3 points, identify what they are, flip them, and then just from the looks of it, this graph, and it's not any special type of graph, it's just a random graph of 3 points connected together, then all of these points are going to reflect over that line. And so, in this case, they're just saying that it's a one-to-one function and you want to graph the inverse. So just identify those 3 and then switch them around. Okay, on this one here, we're simply just doing composition. And in order to show this, we need 2 things to happen. F follows F inverse equals X, and F inverse follows F equals X. All we're going to do is plug the 2 functions into one another and show that they equal X. Now the key word here is show. It's not a yes or no question. It's just show the work to show that these 2 are inverses of one another. And so what we'll do is if I did F follows an F inverse. So when we did composition way back when, I'm going to take this function, plug it into my original function. So 9x plus 2 is going to go in for x. And all we have to do is simplify it. It's just some algebra now. This should be 9x minus 2, though. I wrote it down wrong. What's that? This was 5-1 with the inverses. So as we look at this, all we got to do is show that they equal x. These 2 cross off. And they equal x. Okay, and then we're going to do it here as well. We're just going to go the opposite direction. So we're going to plug f into f inverse. And we want to show that this one equals x2. So if we just do some simplifying here, what would be the first thing that's going to disappear here? If I take 9 times this expression. If I multiply by 9 and I have a 9 on bottom, what's going to happen with my 9s? They cancel. Okay? These 2 are going to disappear. So we have x plus 2 minus 2, and that leaves me x. Okay, so the composition just shows that they both equal x. So you just have to do a little bit of algebra there to show they both equal x. Okay, questions on that one? But the thing is there is they tell you it's an inverse, so you're not trying to determine or anything like that. We already know they are, then we just have to show it. All right, number 9. We're we're trying to find the domain and the range of the inverse. Not the original, but of the inverse, okay? So, here is the way that I would probably set this one up. And you can definitely use your calculator on this one, and I'll show you how that would make this a whole lot easier. Okay, the original function is a rational function, and we talked about those in the last chapter. You can absolutely use your calculator here. If we graph that one, let's just go ahead and take a look at it. For the original function, we're going to say x cannot be negative 7, because that's where that vertical asymptote's at, because of the denominator, right? My horizontal asymptote, we said y cannot be 0. But it wants to know the domain and range of the inverse. Well, just think about what inverse means. Inverse means take x and y and flip-flop them. So if I flip-flop x and y, guess what that's going to do to my domain and range? It's going to flip them, okay? So the range will become the domain, and the domain will become the range. So what we'll say here is x cannot equal 0, and y cannot equal negative 7. Just like we flip it with an ordered pair, we also flip the domain and range, because domain and range represent x and y values, and so the graph is going to flip with that. Yeah?
How'd you get the range as y equals 0?
Okay. If I were to, or I'll just draw a graph up here real quick. So my answer there, I know I wrote my answer a little bit differently. They wrote theirs in interval notation, but which one would that represent? We're looking for the one that represents this right here. Okay, that would be C. X can't be 0, and y can't be negative 7. Okay, in your calculator, put this in your calculator. Your calculator displays this a little bit differently, so I want you to see this, because sometimes we get a really small or a really large number in our calculator, and it displays it a little bit differently. Your e to the power is right above ln, so just hit second ln. We get this really long number, but at the very end of the number, you see this e negative 4. You guys get that on some of your calculators? Hey, when you see your calculator do that, it's saying that your number is really small. It's representing it in scientific notation. So the e really represents times 10. So it's 3.255 times 10 raised to the negative 4 power. In scientific notation, if we have a negative exponent, we're going to move our decimal 4 places back to the left. So we're going to take this decimal and we're going to move it 1, 2, 3, 4. It displays it like that because your number is really, really small. 0.0003255. And if we pick out the one that fits it the best, that would be A. So it's not always going to display your answer like that, just when it's a really small, or sometimes when it's a really large number. And some of you may not have seen that in your calculator before, so I want you to see that. Okay. Everybody good there? Okay, on number 11, it doesn't ask me to graph both, but I'm going to go ahead and graph both. I kind of like graphing both just to see how they go together and how they are transformed or changed. So I'm going to graph the original function first. F of x equals 2 to the x. And we have all kinds of points we could use here, but 0, 1 is a big one. 2, 4 is one. Okay, and that is a growth function because it's growing as it moves to the right. And that's our original function. If you don't want to graph that one, you don't have to because it's not asking us to graph that one, just the new one. Okay, I'm going to do this one in red just so we can see the difference between the two. We don't necessarily have to put anything on the blank, but there's two changes that happen here. What's the -1 going to do to my graph? Right one. And what's the -3 going to do? Down 3. Okay, so the whole graph has been moved right 1, down 3. Can I put this into my calculator? Absolutely. Okay, and I don't have an issue with you guys putting it into the calculator, but what I want you to understand is a couple of things. And these are some things that I'll be looking for when you graph it, is right now, my horizontal asymptote is the x-axis. When I graph this one, the asymptote's going to move with my graph. So my asymptote is going to move right here. This is the line that the graph cannot cross. That's going to be the asymptote. When I put this into my calculator, you'll see that as well. You'll see that it's approaching that line. But that's a really, really important part of the graph. When I put this in, a lot of people will bring that down and it'll and that's why I like to graph the blue one, is because what we're saying is this graph has moved right 1, down 3. So the whole thing, the whole graph has moved right 1 and down 3. So when it says describe its position, that's the part that I'm looking for, okay? And then obviously you gotta graph it to show it as well. Questions on that one? Your calculator is a great tool to use on that one. Use it to help you, to guide the graph and get the information that you need on it. Okay, 12 and 13, I'll have the formulas up here. This is the compound interest formula based on different time increments, so it might be monthly, quarterly, annually, semi-annually, one of the time increments. This one is compounded continuously, and it'll say continuously in the problem somewhere, and we use the PERT formula instead. So you got a problem on each one of those. This one says continuously, so if it says continuously, I know I use the PERT formula. If it says quarterly, then I'll use the other one with the N. Just make sure you know what each one of the variables represents. Okay, I'll have the formulas, but I'm not going to have what R is, what N is, what T is, and all of that. You need to know what each one of those represents and stands for. N is the one thing that could change here. If it's like monthly, it would be 12. If it's quarterly, it would be 4. So that's the one thing that could change. It's not always going to be quarterly. It could be any of those other ones as well. And that's the one that's used twice in the formula because you have an N in both places. Okay. So practice putting that into the calculator. And because you're talking about money, they're going to round the answer to the nearest penny and do the same thing on number 13. Just round it to the nearest penny. So if this was -7, our two branches look like this, and then look like this, okay? And so as we look at our y values are our range, okay? As I move up and down, the one place it's never gonna hit is the x-axis.
So you can just grab that.
Yeah, you can put it in your calculator. Yep, absolutely. That's I would encourage you to do that. And the reason why I say use your calculator is because you can't really graph the inverse. That would be really difficult to do, trying to come up with an equation for the inverse and graph it. So all we're going to do is take the domain and range and flip them around of the original. Okay, 14 is just another plug-in type of question. Okay, it's an exponential function using e, and we don't know t, but here it tells me t is the number of years since 1960. So I want to know how many virus cases there were. Estimate the number of cases since or in the year 2000. So they started collecting data in 1960. 2000 is the year that they're trying to collect data for. So what we have to figure out is how many years have passed. So if I'm going to go from 1960 to 2000, how many years would take place? So we just plug 40 in for t. And then it's just plug it into your calculator and figure out approximately how many cases we're looking at. Okay, so that's just a calculator problem again. Okay, I will also put up this formula for you tomorrow. It's either that or I'll give you a formula sheet 1 and 2. But this will be given to you in one way or another. Going from exponential to log, log to exponential is what we talked about yesterday. How to go back and forth from one to the other. And that's kind of helpful here, and I'll show you kind of a quick and easy way you could do this problem. I know that some of you have the log base button in your calculator and you could just type this in, but not everybody has that, so not everybody has that luxury. And so a real quick and easy way that you could graph this is you could change this log equation into an exponential equation. 4 raised to the y equals x. And you might say, well, it's not solved for y. You're right, it's not. And so here's a little trick that you can do that's a little backwards of what we normally do. Normally, we plug in a number for x to find y, right? But this equation is not solved for y like it normally is. It's solved for x. So instead of plugging in for x, we're going to plug in for y. We're just going to kind of go backwards because we're doing an inverse, right? So if I plugged 0 in for y, 4 raised to the 0 is 1, so my x value would be 1. If I said, what is 4 to the first power, I get 4. And the other thing to keep in mind, whenever you have a log function, as long as you haven't shifted it left, right, up, or down, then it's always going to approach the y-axis. So make sure that your graph doesn't do one of these where it crosses the y-axis because the y-axis is your asymptote. So that's kind of a little bit of a trick to do there. All your log functions should take on this shape right here because it's the inverse of the growth function. And it's just reflected over that y equals x line. These are some of the evaluate type problems that we did. Yesterday we said let's put a box in right here and let's try to figure out what this is equal to. So if I was to rewrite this, I would rewrite it like this, okay? And this looks kind of like it's a difficult problem, but it's really not, especially because look at your two sides of your equation. In this case, they both have a base of 9, right? So if they both have a base of 9, if this is 7/2, what's this exponent got to be? 7/2, right? In order for these two sides to be equal, this box has to be 7/2. So that's my answer, okay? For this one here, you have two options on 16. You could say 9 to what power is 729? Or you could do that log base rule that we talked about yesterday, where you take the log of 729 divided by the log of 9. We're going to see that here again in just a second. But a couple of different ways you could evaluate that. But you're just looking to see what exponent, 9 raised to what power gives me 729. And it's multiple choice, so you could put all of those in and see which one works. And you should probably be able to come to an answer pretty quick based on the answers that are given there. Okay, 18 and 19, you're using this rule right here. And I'm going to give you that rule tomorrow. So all you got to be able to do is, you're not solving or doing anything else. You're just rearranging everything, okay? You're putting it in a new format. If they give me exponential, I'm going to rewrite it as a log. If they give me log, I'm going to write it as an exponential. So you have one of each. You go on from exponential to log one time, and then you're going from a log to exponential one time. Okay. Just putting all that stuff in. $20 is just a calculator problem. Just type it into your calculator. ln of 294. Should be the easiest one on the whole quiz. Okay, the last two. 21 is using the change of base formula. Really, there's two ways you could do this. If you have that log base button in your calculator, you could just type this in just like it is. Some of you have it, some of you don't. If you don't have it, then you would type this in like this. The log of 20 divided by the log of 200. Okay, on this last one, it says T is the number of months since this species was introduced. So they're talking about finding the population of this species that's endangered probably and trying to track it over time. Okay, and so T is the number of months. So T is 40. Kind of like the one we did earlier. The only difference is this is a log equation. The one we did earlier was an exponential equation. So when we plug this one in, it's really just an order of operations question. This is assumed to be a multiplication between the 80 and the log. It doesn't show us multiplication, but it's assumed to be there. We're going to plug 40 in for T. And then we're going to do the order of operations, and we're going to evaluate it. What would I do first? What do you guys think? Order of operations tells us we always do what first? Do what? Parentheses, yeah. Okay. Do all the operations inside the parentheses. 2 times 40 is 80. 80 plus 1 is 81. So we got 300 plus 80 times that whole thing became 81. Okay. Now, before I can do anything else, I have to evaluate that. That is a number. And we saw a couple problems like this just on the previous page. Log 81 base 3 is equivalent to something. 3 to some power gives me 81. So I got to figure out what does this whole expression equal. And then once I know what that is, then I can just finish out doing the order of operations. Okay. And if you need to figure out what this is and you're not really sure, then you can do like what we talked about up here. You can do the log base button. You can do the change of base formula. Any of those things would get that value for you. Questions so far? Okay, I'll come around and help you out if you